Okay, so we solved the system through graphing. We solved the same system using substitution. And now we're going to solve the exact same system again. This y equals 3x minus 1 and y equals negative 2x plus 4. But we're going to use elimination. Okay, so remember with elimination, that means that you can eliminate one of the variables. But look at these two equations. This is not what we're used to. We're used to seeing these equations in standard form. We're used to seeing them in ax plus by equals c form. You cannot use elimination unless you have this standard form. You can't use slope-intercept form. So you need to change this slope-intercept form into standard form. Okay, so what do? Well, you just got to get this over here. So you add the opposite, add a negative 3x to both sides. And now you have negative 3x plus y, because you can't add those together. They're not like terms. That's gone. And it equals negative 1. Okay, so now you have this first equation. You've changed it into standard form. Now you need to change the second equation. Do the same exact thing. You got to get rid of this negative 2x. So you're going to add a positive 2x to both sides. You can't add an x and a y. So you have just the 2x plus the y. And over here, just have the 4. So now you have this one in standard form. So now they're both in standard form, and I'm going to rewrite them over here. So this first equation in standard form is negative 3x plus y equals negative 1. So it's exactly the same equation as this, but it's just in a different form. We started in slope-intercept. We changed it to standard. Now this equation, y equals negative 2x plus 4, same thing. We took it and we changed it into standard form. So now it's in standard form, 2x plus y equals 4. So again, it's the same exact equations. It's just they're in different forms now. Now, we need opposites. As you see, the x's are not opposites and the y's, we know these are 1's, are not opposites. But 1 and 1 is almost opposite, right? If we could just make one of them negative, then we would have opposites. So I'm just going to multiply this whole first equation by a negative 1, which will change all the signs, which will make this negative 1, and then we'll have opposites. It'll be perfect. So negative 1 times negative 3 is positive 3x. And negative 1 times positive 1y is negative 1y. And negative 1 times negative 1 is positive 1. So now I have opposites, and I can go ahead and add. 2 plus 3 is 5x. Opposites cancel out. 4 plus 1 is 5. Divide by 5. And surprise, surprise, we get x equals 1. Again, we already knew x equals 1. We've solved this system 2 other times, right? We graphed it. We used substitution. We're just reviewing here. Now I have my x, I need to find my y. How do I do that? I replace x with 1, okay, because remember I need my ordered pair, x comma y, so I need to find my y. So replace x with 1 in the first equation. Do not use the one that you changed. You could have made a mistake. Always use the original. So I'm going to use this one. And instead of negative 3x, I'm going to do negative 3 times 1 plus 1y equals negative 1. Okay, and I'm going to solve. So this is negative 3 plus 1y equals negative 1. Okay, and then get rid of this by adding a positive 3. So you get y equals 2. And you can divide by 1, but you know that's not going to change anything. Okay, so the y is just 2. And then you should check it, even though we've done the same one several times, by using the second equation, replacing x with 1 and y with 2. So you've got 2 times 1 plus 1 times 2 equals 4. 2 times 1 is 2, 1 times 2 is 2, and 2 plus 2 is 4, so it worked. And so we solved the system through elimination. So that's a review of solving systems through graphing, substitution, and elimination. Let me know if you have questions.